Chapter 18 talks about time series, and as always, we're using stats to forecast the future. Okay, that's in almost every case, that's the point of statistics, to take a sample and use it to predict something with regard to employees, sales, profits, whatever the case may be. Nothing's different here with time series, but it is a different technique. So some of the objectives here have to do with defining what it is and then looking at the type of time series, whether it's moving average or weighting moving average. We're going to 18.5. We're not doing 18.6, 7, or 8. Okay, so a collection of data recorded over a period of time, which we've been dealing with since business stats. There's nothing new there. We're used to collecting data, or at least getting data handed to us. But obviously, if it's data, then someone or some program had to collect it over a period of time. The difference now, though, is looking at the components of it, where we say, is it a secular trend, which means there's a long-term direction of a time series. Secular trends tend to have to do with sales or stock prices, employment patterns. Those usually are secular trends. There's a good example in the book of Home Depot, how that's a secular trend. And then you have cyclical variation, okay, which is just the rise and fall. Many businesses have cyclical variation because it's rise and fall of a time series longer than 1 year. So if the data starts dropping over a lengthy time period, more than a year, we call that cyclical changes or cyclical variation. Seasonality, patterns of change within a year, which tend to repeat each year, just like the word says, seasonal, meaning as business picks up around Christmas time, and then we see that happening every year, then it starts to fall off again around February, as we see in retail. That's basic seasonality. And then you have irregular. Sometimes you have an oil crisis, so we have irregular variation as well. Secular trend, the smooth long-term direction of a time series. We have number of associates here and the years that account for those associates. And so you see, right, if we were to plot these numbers here, it would be the green line. But there is a way you can, it's called smoothing. You can smooth that green line into a black line. That's what we're going to learn today. Cyclical variation as well looks like this. If you recall from your macroeconomics class and your other classes, you have situations where business cycles exist, as it says right here, basically, right? You have prosperity, depression, contraction, recovery. So you have a basic business cycle, and you can smooth that data to be more like the black curve. And then seasonality, you'll notice, for example, in, you say Q3, right, the sales tend to be lower. So Q3, look at that number right there. We have about a 3.5, another Q3, 4.4, and another Q3, 4.6. So sales tending to be lower over a consistent period within a year as you go year to year. That's what we call seasonal variation. And then we have episodic and residual, also known as forecasting error. So the point of the story is there are many types of variation or trends in data, and you'll be asked to identify the types of variation in particular questions. So the moving average method, how do we get data that might look like this or look like the green line here to be more smooth? Because the smoother it is, the more linear it is, the better you can use the data as a predictive tool. The more erratic the data is, the more challenging it becomes to use it as a predictive tool. Okay, so that's what we're learning here. So the moving average method, useful in smoothing time series to see its trend. Okay, it's a basic method, and it's applicable when there is some relative linearity, okay, or fairly linear trend. Okay, so here's a quick and easy example, right? You have sales from the period 1988 to 2013, okay? And what we're doing is creating a 7-year moving total. Now, Look at this sales column here. Which line, green or orange, represent this data here?
Yeah, I think it would have to be the green one.
Exactly. Right. It'd be the green one. So the green one is quite erratic. Okay, quite erratic. Meaning it'd be very difficult to make any predictions. Yes, it goes up and down consistently, but to make predictions, it's always better to have a relatively straight line or a linear curve, which is the same as a straight line. So one way to do this is to create a moving total, okay, or a moving average. Now we're going to choose, or the book has chosen 7 years right here, okay, 7-year moving total. You can choose other years. You can choose a 3-year, a 5-year, a 7, 9. You can even choose a 4 or 6. It's up to you. Typically it's odd, but sometimes you will see a 3-year, as we'll see later. It just depends on what it is that you're trying to do. If you want a shorter time series in the long run, right, then choose a larger year moving total, okay? So let's look at this data here, and we see 1, 2, 3, 4, 5, 4, 3. That's our first 7 years, and we want to convert this this data into a 7-year moving total. So if I take out my Excel here, all right, let me just put it right here. What I'm going to do is put 1, 2, 3, 4, 5, 4, 3. Okay, and those are the years that the first 7 years I have right here. So if I look at this, I now see I have 7. Here's my count of 7. Okay, and here's my sum of 22. So here's the 22, right? So I know I'm good. Now, look at this average, 3.143. That's the same as this number here, 3.143, because that is the average of these 7 numbers. Okay? And so that's the number I want to use for my first point in my newly constructed column called the 7-year moving average. So 3.143 is the number I'm interested in. Okay? This number here, not so much. I just use this for kind of explanatory purposes, but really I'm interested, this is the average. Okay? That's why we call it moving average, whereas this is the total. Okay? So we typically focus on the average. Now, why do I put it here in year 4, right? This is year 1, 2, 3, 4, right? This is the 4th year in the set of data. Because, and in standard practice, you have 7 years. If we take that and divide it by 2, we get 3.5, okay, 3.5. And that 3.5, if we average it up, if we round up, gives us 4. Okay, and we start in the 4th year when we start to locate our data, when we start to place our data in its new column called the 7-year moving average. So this is 1, 2, 3, 4. This is the 4th year. We're going to start right here if we are dealing with a 7-year moving average. Okay, if we were dealing with a 5-year moving average, we would take 5 and divide it by 2, and that gives us 2.5. And if we round that up, that is 3, which means we would start in year 3 with our data. So we would go 1, 2, 3, and we'd have a number right here in year 3. So that makes it very simple to begin the location points for your new data set. Okay. If you mess up and put it a little higher, a little lower, will everything fall apart? No, the lines will still look very similar. But as is common practice, you want to take that number in terms of the number of years, divide it by 2 and round up, and that's where you start, and that's because we want to be consistent with placement. Okay, so we see where we get the 3.143 right here, just the average of these numbers. Let's try and get the 3.286. What I'm going to do is I'm going to add the next number, 2, to the data, and this 2 is the same as this 2 right here. Okay, that's the same number. And then I'm going to take the next set of 7 numbers. So I'm going to leave the 1 alone. I'm going to start now with 2 and go all the way down to 2 because these are the next set of 7 numbers. So 2, 3, 4, 5, 6, 7. I'm sorry. 1, 2, 3, 4, 5, 6, 7. Those are 7 numbers right there. And if I were to actually plot this, I would confirm, okay, the sum is 23. Here's 23. And then the average of these 7 numbers from 2 to 2 is 3.286. 3.286. If you do that consistently all the way down, you will get a set of data that looks like this. Okay, any questions there?
What did you say? What do? You dividing 2 by the number, by the sum in order to find out where to locate the first data?
Oh, you're taking the number of years, in this case 7, and you're dividing it by 2, and that's going to give you 3.5.
Okay.
Okay, you want to round that up to 4. And then you look for the 4th year, okay, 1, 2, 3, 4, and that's where you begin your set of data analysis.
Okay.
Okay. Then after that, you get to worry about doing that anymore because obviously the next set will be right below it, and you keep going.
Okay.
Okay. So just keep that in mind. You take your number of years, divide it by 2, round up, and that's where you begin. Again, in the real world, if you mess up, if you put it in 1 year above or 1 year below, not the biggest deal, but you tend to want to be consistent, especially when you're first learning this, especially in Connect. Okay, so that is how we look at a moving average, the moving average method. Okay, and if you were to plot this, right, then you have the orange line, which obviously is a more linear curve. Okay, if you were doing 5 years, okay, 3 and 5 year examples. So let me bring back Excel. And if we are doing 5 years, no, let's start with 3, and the first 3 numbers are 5, 6, and 8. Here's 5, here's 6, here's 8. Let me grab those numbers, look at my counts of 3, my sum is 19, here's 19, and here's my average 6.33, and there's 6.33. And why do I start here in the second year, 1996? Because 3 divided by 2 is 1.5. 1.5 rounded up is 2, so I start in year 2. What's year 2? Here's year 1, 1995. Here's year 2, 1996. So 6.33 begins right there. Okay? And I can continue that process all the way down to get a 3-year moving average. Okay? And then if I want to do a 5-year, okay, same logic. 7 years, same logic. Just different, you're going to get different averages, of course, and you're going to get different starting points. So if you compare the green line, which represents this production Y line, with the orange line and with the, I guess that's purple line, you can see that the orange and the purple line are smoother, are more straight than the green line, which of course is the point, to have a smoother and straight representation of the data. Okay. The weighted moving average. So now we get to a system where we are going to weight the data that we're working with. A simple moving average assigns the same weight to each of the average observation. Weighted moving averages assign a different weight. Okay? And typically, if you are weighting, the more current or recent observations receive the most weight, and the weight decreases for older values. And last, the weights, of course, as in all weighting, must equal 1. The weights must equal 1. Okay? So we have Cedar Fair operating 7 amusement parks, combined attendance for the last 20 years. Here we go. A partner asks you to study the trend, and you want to compute a 3-year moving average using weights of 0.2, 0.3, and 0.5 for successive years. Okay? So if we were to plot this data, it would look like this green line. But if we were to weight this data, it'll look more like the orange or the purple line. Now in this case, we don't see much of a change. this data is simply just a bit erratic. That's just how some data ultimately is, which is why I'm glad they gave it. Every data does not come out perfectly when you weight it. But it is a bit smoother over the 3-year moving and the 3-year weighted moving average than it is with the green. So it's a little smoother. That's why we do this. Now, the question is, how do we do it? Well, the first thing we want to do is look at the data itself and say, okay, do I understand the data? In 1993, I have, really, this is in millions, right? 5,761,000 people in attendance. But if you just benchmark it to 1,000 or simplify it to 1,000, you can just say 5,761 people in 93, 6,148 people in 94, etc. How do I create the moving average? Like this. So, and I did a little bit of this earlier just to save time. All right, so I've output the data to Excel. There it is, and I put the data on my website. It's this one right here. Okay, so you want to grab the weighted moving average, download that file. When you download it, you will see this. Only this will come up right here. Okay, and then you got to do the work to get this one. So put the slides back up. So the work is first, and then actually let me do it right next to it so you can see it live. So I want to take equals, and I want to multiply this number times the weight 0.2. And I want to lock that in. Okay, I want to lock that number 0.2. Close parentheses. Then I want to open up another parentheses and grab the second number multiplied times 0.3, and I'm going to lock that in. And you'll see why I'm locking it in a moment. Then I'm going to add the third number, because it's a 3-year average. I'm going to multiply that times the final weight, and I'm going to lock that in. Okay, so which I did not do. There we go. F4, keep in mind, is your locking shortcut if you're dealing in Windows at least. So F4 is your locking shortcut. It'll give you the $ around whatever cell you're in. All right, so there's where I get the 6388. Again, I multiplied each of the first 3 numbers times their respective weights. Okay, and then year 3 times this weight. And remember, just like the information gave us before, right, most recent observations receive the most weights. That means the latest year, the most recent year in your set of years, in this case there's 3, receives the highest weight. So let's see if that's actually what happened. So the most recent year in a set of 3 years is 1995, right? Our first set is 93, 94, 95. So the most recent year is 95, and that receives the highest weight of 0.5. Okay, so we are following that prescription. The earliest year of 1993 receives the lowest weight. Okay, so as is standard practice, you want to put the highest weight in the most recent year within a weighted moving average system, whether it's 3 years or 5 years. If this were 5 years, then 1997 would receive the highest weight. And of course, we have to change the weights to equal 1, giving all of these different numbers. Okay, and that's typically because your more recent years reflects your best data, right? In 1993, you were collecting data, but then you've improved your data collection practices. So in theory, the most recent year reflects the fact that you were better at collecting data, right? Something about your systems may have changed, and so you tend to want to give your most recent year, or your most recent year numbers a bit more emphasis in the construction of the 3-year weighted moving average. So after I compute that number, I get 6388. Of course, I start in year 2 for the reasons I explained earlier. And I can now drag, right? I drag these numbers down, I'm done. If I did not weight, right, notice, if I did not lock these weights in, When I drag, it will get quite messy. It will be wrong. It's because I lock these numbers in, these weights, I'm able to drag and complete this so quickly. Okay? All Excel is doing is when you drag, it's going to take the next 3 and multiply them times the locked numbers. So now look at this, right? It's taking the next 3, 94, 95, 96, and look what it did. It took 94 times F2. There's F2, that's the first weight. It took 95 times F3, etc. Okay, I can go down here. It took 2002 times F2. It took 2003 times F3. That's because I locked them. If you don't lock them, these numbers will continue to move and you'll be taking blank cells times these numbers, of course, which messes everything up. But if you lock them, when you begin to drag, Excel's going to drag downwards in sets of 3 on attendance, but it's not going to drag downwards for the weights because they are locked. Okay? Any questions on that?
No.
Okay, and I gotta say, it's very important that you practice that a lot. Okay, that's not something you want to come, and you've done it before. We've locked before. We've locked in business stats if you're using Excel. So nothing new, but in terms of indexing, it is new. So make sure you practice that. Okay, and I can do the same thing to get 5-year weights if I choose to. So nothing, and like I said before, there is not a lot of change in terms of the visual here, but there is some smoothing that took place. So when we compare the 3-year moving average, the orange, to the green, and we compare the purple to the orange and then to the green, we see that we smoothed out just a bit throughout the data. And who knows what a 5-year, maybe a 5-year smooths it out even more, maybe a 7-year smooths it even more. So that's the practice that you would undergo.